Greetings and welcome, friends. Yesterday we started talking about the idea of measures of variation. If I could describe a whole bunch of numbers with a single value that would describe how spread out they are, how densely packed or dispersed they may be. And today we're going to talk about this super valuable measurement. Okay, just like I might have a number that describes the length or width or area of a square or, right, a rectangle or a triangle, this is a valuable measurement for a lot of data points. Now, you're probably looking at this formula and you're like, this is the most horrifying thing I've ever seen. I don't even know what some of these symbols are. This is Greek to me, and you are correct. This is literally Greek. That is the Greek letter sigma over here. There's a little lowercase sigma for you. By the way, capital sigma looks like this. But this is what this is about. So ready? Track with me. The standard deviation. You with me? All right. The standard deviation of a numerical data set is a measure of how much a typical value in the data set differs from the mean. I'm gonna call that how spread out. All right. How far, on average, a point is from the middle. Okay? That's what we're trying to describe. How spread out is the data. All right? The symbol sigma represents the standard deviation. Deviation would be a word that describes, right, how much something deviates from the normal, okay? And it is read as sigma, all right? That's what letter that is, Greek letter sigma. And it's given by this crazy-looking equation. Look at this, equation's even got dots in it. They were like, we don't have time to fit all this. You get the idea, ... Right? Like, what is going on here? Okay. And then they tell me some of these things. N is the number of values in the data set. It looks like at the end they're dividing by n. All right, they're dividing by how many points of data we have. It says the deviation, here, Jake, be quiet, of a data value x is the difference, so I'm subtracting a data value, and the mean of a data set. So I'm going to be taking a data point and subtracting x bar. Remember how we referred to mean as x bar? So if I'm looking at this formula and thinking about standard deviation, all right, thinking about order of operations even, I want to just communicate what these are. So x1, x2, x3, x4, all the way to xn is literally like my list of data points. So I'd have x1, x2, x3, x4. So those are referring to individual data points, of which how many data points do I have? How many values do I have according to this? Well, there's an ellipsis. It's suggesting that the list could be more than the ones I've labeled. But if I have 1, 2, 3, 4 more numbers all the way to n, how many data values do I have? You can pull that from here or here. There are n many data points, okay? N of them. All right? And so the number of times I do these subtractions is going to depend on how many data values I have. All right, if I only have 2, then I do this twice. If I have 10, I do this 10 times. That's what that's referring to. Now, according to order of operations, where would I start? Would I start by taking this as a square root? I would start at the innermost parentheses, right? So this is a grouping symbol. I need to start at the numerator, but within that numerator, I have individual parentheses. So before I square those, I've got to work in here. And within there, what I'm going to do is subtraction. Okay? But first, I might have to even find out what x bar is to get us started. So here we go. So we've got some steps. Yep, yeah, it does that when I copy and paste from my notes. Let's see, how well can I line that up? Guys, oh, did I do it? Look at that, seamless. That's amazing. Look at that. You can't even tell. Talk about accuracy, my friends. Man, that I just like 360 no-scoped that. Did you spot that? Woo! Man, that's insane. So anyways, so the first thing I've got to do is figure out what the mean is, x bar, all right? And we've done that before. Notice that all of these subtraction problems have an x bar in it, right, Kaylin? You can face forward, thanks. So I'm going to do that, and then I'm going to find the deviation where I subtract those things, right? The innermost operation is subtraction, so I'm going to do some subtraction. After I subtract, what can I do with these parentheses? What's the next thing after I subtract? Then I'm going to do, yeah, this exponent, so I'm going to square it. That's why that's the next step. And then after I square that, what does it look like I do with this thing and more things and this thing? Well, what's it look like they're doing? I've got to add up all of those things. All right? So it says, okay, you're right. All right, I see why you said the mean. You're right. You're right. Come on now. Come on. Help yourselves out. Don't hurt your friends mathematically. Let's see. So I need to find the mean. You guys remember how to find the mean? I like it. Add up and div by how many there are. Right? And notice that's what they're doing. Look at this. They're adding these things up and then dividing by the number of them. Okay? That's what's happening here. They're adding them up and then dividing by how many there are. And then what's the last thing that we haven't done yet? What operation? Right? Okay. All right. Yeah, take the square root. So yeah. So notice the square root is the last thing. It's the outermost thing going on here that we're going to do. So there's a lot of steps here. Good news, you have those steps written down. Good news as well, I made a table for us for our first problem. Now, you might be like, well, Mr. Wadi, why do I want to do this? How is this going to help me? Now, standard deviation is going to give us a single number that describes how densely packed or spread out the data is. All right, that's what standard deviation is going to do. So it says a small number means that the data is clustered around the mean, it's densely packed. A large standard deviation means that the data is more spread out. So just like range does that, describing how spread out the data is, standard deviation is going to do an even better job. It's going to describe, on average, how far is any point from. Okay? So let's look at example 4. Example 4, here we go. You're so excited to use this formula. All right, here we go. Find the standard deviation of the ages in show A from example 3. Hey, good news, friendly friends. I done doodly did that for you. I made a nice little table for us. Look at this. This is beautiful. Okay, so I've made a table for us. Here's a set of values. Question, how many values are there? There are not 31 values here. So I'm just going to point out that n equals 12 here. There are 12 data values. Yep. And if I want to find the standard deviation, so you guys have this table. Quiet, please. Follow along. Help each other out. Okay, that's just the name of it. So I would refer to 20 as x1, 19 as x2, 25 as x3, etc. All right, x sub 12 would be my last value, which is 31. These don't happen to be in order, but that doesn't matter. So guys, the first thing that this formula asks me to do is to find the mean. Okay? So let's find the mean of this. So I'm going to call this x bar up here, x bar. How do I find the mean of those things? Add them all up and divide by how many there are. Ready? I'm going to give you guys some calculadoras. Hang on for a moment, internet friends. Feel free to go take a quick break, internet friends, and go grab your nearest, most enjoyed calculator. That's right. Here on Waddy Math, we like to use the Texas Instruments TI-30X2S, a classic calculator in a dark navy blue color. It's amazing. It's got a nice texture to the plastic. The buttons have some beautiful clacks that they make when I push them. Oh boy, here we go. Brought to you by Texas Instruments. All right, friendly friends. Let's see. Let's do some math here. Tell you what, actually, let's get real on this. We'll end up doing this a couple different ways. On the test, though, you are going to be using a table here. Oh, look at this, beautiful. Ooh, look at this. Oh, ooh, there we go. There's my nice ring. Here's my calculator. So, guys, so what I'm going to do is add these up, right? That's how I find the mean. I got to add them. All right, so here we go. Here's your on button. Ooh, looks like, oh man, guys, I don't remember doing that math, but that's pretty great. All right, so I can clear that out. Clear, button right there. Let's see, how are my fingernails doing? Yeah. So, let's add these up. So I'm going to do 20. Looks like a plus sign right here. Plus 19. Oh dear, I hit enter accidentally instead of plus, but that's fine. 39 is just the sum of these first two, so I can just hit plus. Doesn't matter. And what do you think ANS means? Answer. It's going to take my, 39, and I'm going to add 25, and watch, I'll just keep hitting plus. Plus 30, plus 21. Now, guys, realize I'm not going for a speed run on this right now. I'm just kind of demonstrating. We'll do some calculator speed run videos later, where I'll show you all the Easter eggs on this TI-30X2S. That'll be pretty good. Let's see, looks like I'm at 29 next, plus 22, plus, all right, 29. Let's say I messed up. What if I went, oh no, guys, I did it too many times. I got 299. Yeah, we could hit the delete key. Another thing you can do is actually use these arrow keys to move back and forth. All right, so that way you don't have to start over. Let's see, which 29 was I on? I think I was on the last one. Yeah, so 20 plus 31. I hit enter. So ready? So my scratch work for X bar, I've got 300, and I divide by the 12. I agree. And watch this. Do I have to type 300 again? No, I just hit divide. It's going to take my previous answer, 12, hit enter, bam, 25. So, guys, check this. I've got 25 as my mean. Yeah, put that in your first column for your X bars, so 25. And you could write all of these down, but you know what? I'm not going to make you. Here you go. All of those are 25. At least write the first one down. Because when I grade you on this, I'm going to be looking to see whether or not you get that. All right, what's the next thing I've got to do? It says find the deviation of each data value. Take your data point and subtract the mean. So this column is going to be X minus X bar. So you guys ready for this? How do I calculate this first cell? What do you think I would write in here? I'm going to take 20 and subtract 25. Almost, -5. So some of these you might be able to do in your head. If not, you could use your TI 30X2S. So for instance, I could do, let's do 19 minus 25, enter, -6. Uh-oh. Guys, what do these subtract to be? All right, that's cool. Hey, here's a positive one. 30 minus 25 is going to be 5. 21 minus 25, -4. This will be +4. All right, all right. Yeah, catch up to me. 27 minus 25 is 2. All right, there we go. All right. You'll be doing the same thing on the homework. And I'll try to post this video in time so that you can follow along with me at home. This is example 4, right? That's the notes. The homework is later on in the packet. Yeah. Don't you worry now. Okay, guys. Next thing I've got to do is square these numbers. Okay, so this next column is x minus x bar all squared. All right, guys, you ready for this? Square -5. What does -5 squared mean? Yeah. What does it mean to square that? Yeah, multiply it by itself. So -5 times -5 is? What's -5 times -5? Okay, I bet I know what you did. You done? Ready for this? Ready? If I type in -5, there's a difference between these two buttons here. All right, let me actually refocus this. Ready? Crispy. There we go. This is a minus sign, which means subtraction, all right? This is a negative, which is not subtraction. Now watch this. I could easily do this wrong. Watch, I just did -5, and if I hit square, there's squares button right there. This is actually going to give me the wrong answer. All right, good call. Kaylin just told us it's actually going to equal regular 25. Some people call that positive. Positive 25 because a negative times a negative will be positive. So if I want to enter this correctly into the calculator, I would actually have had to go parentheses -5, close parentheses squared. That will be the positive 25. So be careful, my friends, of user input. So this is 25. -6 squared is going to be 36. 0 times 0 is 0. 2 times 2 is 4. 5 times 5 is 25. The nice thing about these is that these are actually all going to be positive. 16, 16, 9, 4, etc. Okay? So I just square all of those differences. Yep. Okay, next thing it asks is find the mean of the squared deviations. This is called the variance. So the variance, what I'm going to do is take all of these and find their average. Sometimes the variance is also called sigma squared, but you don't have to worry about that. So guys, let's add these all up. And what do I divide by? Guys, how many of them are there? How many are there? 12 of them. Same as this number, right? It's going to be the same value. So I'm going to add them all up and divide by how many there are. What is your claim? Can someone else verify? Let's see. 25 plus, well, actually, would it be 14.6? Oh, 15 would be way too much of a roundup. So I get 176. I'm just showing a little bit of my work so that you guys can follow along. And I've still got to divide that by 12. And I will get approximately 14.6 repeating. Well done. Now, if you wanted to round that, let's round to 2 decimal places. Because this number is bigger than, or 5 or bigger, I'm going to round this up to 14.67. Okay? So we'll use an approximation. And what's the last thing that I've got to do? All right, I take the square root of this value. So this is my actual sigma. And let's see, how can I do that on a calculator? Does anyone know? It'll actually be the opposite for this calculator, but you are correct. Some have you do the number first and then hit square root. Our square root button is right here. It's in blue. So what I'm going to do to access that feature is by hitting second. You can see it even indicates there. And square root. And instead of entering 14.67, watch this. You ready for this pro tip? This is, guys, this is a classic Easter egg for the TI-32X. You ready for this? Yeah. You don't get this sort of stuff on other calculator channels. Oh no. Ready? I'm going to hit second again. And what's this right here? Answer. So instead of entering that value again, I just hit second answer and then get it, and I get 3.8297. And so I'm just going to round that to 3.83. This is what is called my standard deviation. Question. Oh, you'd probably have to go to like insert symbol and then in a list, try to find Greek. See if you can. Yeah. So guys, what does this number mean? What does it represent? It is, now remember we took an average here. It's the average distance that any data point was from the mean. I'm going to say that again. This is super big concept. Ready? This number is the, so to speak, average distance that any one of these values is from the mean. That's what it's trying to describe. If this number is small, that means they're all really close to 25. If this number is big, it means they're far away from 25. Notice if I look at these numbers, it's kind of like the average of these numbers, almost. Except I squared and then I square rooted a little bit as well. But yeah, so there we go. 3.83 is the standard deviation. So my interpretation is that the data are close to the mean. I'll just say closely. They're closely packed to the mean. All right? That's what that means. If that number's really big, then that means they're far away and they're all spread out. All right? The same idea like we were talking earlier, it's about consistency. Okay, let me show you how to do this on a spreadsheet. Y'all ready for this? All right, here we go. So here's my spreadsheet with some stuff already in it. Let's see, I'm even going to bold that for us. Here's the same values. You guys can access this. It's example 4 on the same data sheet for this chapter. The first thing I've got to do is find out what X bar is. What does X bar mean? What does X bar represent? It's the mean. So I'm going to do that for spreadsheets. How do I find the mean? Equals average. All right, well, follow along with me on your Chromebooks if you can, because this might be a helpful tool for you tonight. Now, watch this. This is going to be interesting. This is going to get messed up. You ready for this? What happened? Watch what's highlighted here. Look what's highlighted there. Look what's highlighted there. Yeah, it's finding the average of just those numbers. Oops. Let me show you a pro tip for spreadsheets, guys. Man, I'm showing you all the Easter eggs. Like I said, this isn't a speed run today. This is like 100% complete standard deviation lesson right here for you. Watch this. I'm going to lock it at A2. The way I do this, click on the 2 in this formula and put a $sign in front of it. It's like I'm bribing this formula. You stay right there. Don't you move anywhere, formula. I'll pay you $1. And then I want the end of this list to also be the same. So right before the 13, I'm going to throw a $sign at it. 13, don't you dare move when I drag this formula. I'll pay you $1, right? And now when I hit enter, doesn't seem to do anything yet. But when I go to drag down, watch this. Bam. It keeps that formula locked. Man, keep it locked. Man, that's so great. Feel free to use that soundbite in any sort of cool like music video that you're going to use my voice in later on in the course. Because I know you're all going to be scouring my videos for the best sound effects to make into ringtones or cool dubstep songs. Yeah, that'd be so cool. Make like a Mr. Waddy platformer, and then like one of my catchphrases will be, keep it locked. And then like, there, you've already got 3 audio takes of the same file, so you could actually have some variation in the way that my character says it in the game. All right. Or this is when I come into the boss fight at the end of the level. You guys ready? I'll say, keep it locked? When my character's a little bit nervous that time, right? I'm like unsure. Am I going to be able to beat the boss? And then here's my dying sound effect. Ah! All right, that's a good one. Feel free to use that, because the boss crushed me and I didn't keep it locked. All right, so the next thing I need to do is x minus x bar. You ready for this? Equals. Where's my x? Over here. And what do I want to do? I want to subtract x bar, which is right here. Enter. -5. Where did we see -5 before? Right done doodly there, friends. And watch this. I'm going to drag this down. I don't want to keep it locked this time. And look at this. Look at this list. Oh, thanks, spreadsheet. You just gave me those same numbers. That's beautiful. That's beautiful. All right. So next thing, I'm going to square those numbers. So watch this. I'm going to hit equals. I want to take this number and square it. What does it mean to square it? So one of the ways I could do that is using the asterisk button above the 8. You guys know where that is? Shift 8. That's one way I could do it. So I could do C2 times C2. That'll square it. Another way I could do it is the following. I could use this little caret button above the 6 and say 2, which means to square it. All right, that's just how your math on a computer works. I drag this down. Look at that. There's all those squares. Have I seen those numbers before? Same thing. No, you've got to know multiple tools. I'm showing you all the tools, my friend. All right, next thing I want to figure out is variance. And how do I do that? I find the average of these. So average. Did we see that? Uh-oh, guys. Something went wrong. Guys, do you see an error in my calculation? 9, 4, 16, 25, 36? Yeah. Wait a minute. Friendly friends. 25, 36, 04. 25, 36, 04. 25, 16, 16, 9. That's weird. Guys, that makes me suspect, what if I did this wrong over here? It's possible. But multiple ones of us got that. You know what I might suspect? What if we accidentally did the 16 only once there? But that still wouldn't have made it up to... That's weird. But either way, friends, that might be wrong. Actually, you know what I could do? Yeah, I'm verifying this. This original number was wrong. No. Wait, ready? Mr. Waddy was wrong. There we go. I just lost the boss fight. Don't worry, I'll respawn. I'll try again. Not like I'm going to stop playing the game just because I died once. Please. Okay. So this value is the correct value. Now, I didn't have you fill out this whole column because it's an average. And then the last thing I do is I need sigma. Actually, one of you guys, let's see if I can find the Greek letter. Insert, oh, they might not have it. They have it on Word docs. Insert symbol, it's usually there. Oh, it's okay. How do I find the sigma? I gotta take the square root. You guys have any idea how to take a square root on a computer? Ready? SQRT. Parentheses. Square root. Enter. There's the actual answer. Did you type it correctly? Verify. All right, so ladies and gentlemen, what this tells me is that the actual variation of any data point from 25 was about 4.2. Okay? Now watch this. You ready? Here's a super pro tip. I'm still going to have you do this by using a full table by hand, but watch this. Equals S standard deviation. Look at this. This actually has a standard deviation formula built in. Now, the one that we're doing is with a P there. So we're going to do standard deviation population, open parentheses. Watch this. You guys ready? Drag this down on the original data set. And look at that. It's already telling me. Hit enter. Look at that. Because we calculated this all using, well, we did it all by hand. Then we did it all using a table. And it turns out it can give you the answer all in a single cell if I just used the formula from the very beginning. A2? Yeah, I was selecting just the data set. If I did include 1, because this is a letter and not a number, it still would give me the same thing. Do you have the P at the end of standard deviation? It should be the same. All right. So friendly friends, we're going to have you guys do this activity right now on monitoring progress question 4. All right. So internet friends, if you're following along, we're going to do the very next one the same way. All right. So here we go. I'm going to say bye to my internet friends, but we in real life, we're going to keep working. Have a great day.